All right, we are calling this Chapter 2, Section 7.5. It's really 2.7 in the textbook, but this is about rational inequalities. We talked about polynomial inequalities before. Now we're going to talk about rational ones. We're going to use the fact that the value of a rational expression can only change signs at its zeros and its undefined values. These two types of numbers make up the key numbers of a rational inequality. When solving a rational inequality, we begin by writing the inequality in general form, that is, with 0 on the right side of the inequality. So that is going to be our first step. Our first step is get one side to equal 0. We're going to subtract the 3 over. And when I do that, I have 2x minus 7 over x minus 5 minus 3 is less than or equal to 0. Now notice this gap I left because this is really a 3 over 1. And I need to get a common denominator in order to combine these two pieces. So I'm going to multiply this by x minus 5 on the top and x minus 5 on the bottom. So I end up with 2x minus 7 over x minus 5 minus 3x minus 15 over x minus 5 is less than or equal to 0. Now please remember that when you combine these, I want to switch this and distribute the minus. So it really becomes plus negative 3x plus 15. So when I combine, I get 2x and minus 3x makes minus x. Minus 7 plus 15 makes plus 8. All over x minus 5 is less than or equal to 0. Now we need two things here. We need what makes this undefined. Well, what makes the denominator 0? That's 5. X can't be 5. That is definitely one of our key numbers. The other piece is what makes the numerator 0. Well, that's x equals 8. That is my other key number. So my key numbers that make my number line, just like when we did polynomial inequalities, I have 5 and 8. If I plug in a number less than 5, let's say I plug in 0, I get a positive over a negative, which is a negative. Something between 5 and 8, let's say 6, I get a positive over a positive. And something bigger than 8, let's say 9, I get a negative over a positive, which is negative. I'm looking for less than or equal to 0, so I'm looking for my negatives. And notice the or equal to means that I will use those endpoints. So my answer is negative infinity to 5 with a bracket, or 8 with a bracket to infinity. And there's my answer. So, same type of thing here. We're going to get one of the sides to be 0, preferably the right side, so I'm going to add my 3 over. I get x minus 2 over x minus 3 plus 3 is greater than or equal to 0. I left myself a lot of space so that I can get that common denominator by multiplying my numerator and denominator by x minus 3, which makes x minus 2 over x minus 3 plus 3x minus 9 over x minus 3. Combine those two numerators, I get 4x minus 11 over x minus 3 is greater than or equal to 0. My key numbers that make the denominator 0 would be x equals 3. And to make the numerator 0, I just have 11 fourths. 11 fourths is just less than 3. So that's how my number line will be set up. Plug in something less than 11 fourths, let's say 0, I get a positive. Between 11 fourths and 3, that's going to be a tricky one. Let's do 11 eighths. I am going to get a negative. And bigger than 3, let's try 4. I get a positive. Since I'm looking for greater than or equal to 0, I want those positive sections, and I can include my endpoints because of the or equal to part. So I have negative infinity to 11 fourths with a bracket, or 3 with a bracket to positive infinity. There are my answers. And for some reason on these examples, I really liked 3. We're going to do the same thing. We're going to get the right-hand side to 0. So I'm going to subtract my 3 over. I have 4x minus 1 over x minus 6 minus 3 over 1 is greater than 0. Get that common denominator by multiplying by x minus 6. I have 4x minus 1 over x minus 6. I'm actually going to turn this into a plus and distribute negative 3 this time. So negative 3x plus 18 over x minus 6. Just makes it a touch easier when I combine my like terms to get me positive x plus 17 over x minus 6 is greater than 0. My key numbers now, what makes the denominator 0? It is 6. What makes the numerator 0? Negative 17. Make my number line, I put negative 17 and positive 6. Plug in something smaller than negative 17. Let's go negative 18. I get a positive. Plug in something between negative 17 and 6. I like 0. I get a negative. And something bigger than 6. I like 7. I get a positive. Now I want strictly greater than 0, which means I'm looking for my positives and I don't include the endpoints. So I get negative infinity to negative 17 with a parenthesis, or 6 with a parenthesis to infinity.